The Lake District is underlain by some very old and hard rocks, which makes it a high mountain area, the highest mountains in England. The rocks go back to the Ordovician period, 450 million years ago or so. At that time, this part of the world was south of the equator, in a tropical area, and was ocean, with a continent on either side of the ocean that was slowly closing. As the two plates collide, the rocks are folded and fractured into major fault zones, and this happened time and time again. The core of the Lake District, the highest and most rugged fells, are made of the volcanic rocks that resulted from this collision. The frictional heating, as well as the raising of the temperature as the rocks are plunged back down into the mantle of the earth, causes melting, and some of those magmas, the molten rock, rises up through the overlying crust and erupts onto the surface of the earth. Many of these eruptions became violent, causing a lot of ash and rock to be thrown high into the air. It then settles out, sometimes onto the islands, the volcanoes themselves, sometimes into lakes or seas, where they winnowed out and settle down into fine layers of ash of different sizes, depending on how close they were to the eruption and which way the wind was blowing on the day. Other ashes were very coarse, indeed not really ash, but boulders the size of fridges and small cars. Given the number of volcanoes that must have been erupting in the area, it's very hard to identify the actual vents themselves, the actual sites where these volcanoes push their way through to the surface. What we see is some 6,000 to 7,000 meters of lava and ash and agglomerate thrown out by these very violent eruptions. Later, the volcanic activity moved away from this part of the world, and the area now that is the Lake District was a deep trench right along the boundary of these two plates, one subducted under the other. A continent had been drifted in on top of one of these plates very close to the Lake District. The continent was being heavily eroded by the weather of the day. Silts, sands, muds washed into the sea, rushed down the steep slopes from the coastal belt down into the ocean trench, what are called turbidite currents, forming greywackies, sediments that are sometimes poorly sorted because they've slumped off the slope of the continental sea down into the deeper water and settled out without much sorting. To the south of the Lake District, these sediments can be seen outcropping in the hills around Grizedale and right across South Lakeland. They're softer hills, lower hills, usually below 1,000 feet, often wooded, rather than the bare moorland hills of the Central Fells. They were more easily eroded by the glaciers. It's a slightly softer rock into more rounded shapes. And they contain fossils, things such as trilobites, brachiopods, which can be picked out from some of the outcrops and allow us to date these rocks to about 420 million years ago. Over the next tens of millions of years, that mountain range was eroded until it was returned to a shallow sea. Coral reefs and other fossils that lived in those shallow, warm marine seas create the Carboniferous limestones of about 360 million years ago. This in turn was uplifted during a gentle doming of the Lake District after we had drifted into a desert climate. And so the rocks that lie above the limestones are red sandstones from the Permian period, sandstones that would have been blown by the wind as sand dunes and run across inland flash floods and lakes to be deposited. And it was the erosion going on at this point in time that began to expose the older core rocks of the Lakeland Fells, the Borrowdale volcanics now being returned to the surface by this erosion. And so from the Central Fells moving outwards to the edges of the Lake District in any direction, you move through that geological history from the volcanics into the deep water sediments, into the shallow water corals and limestones of the Carboniferous, and then into the red sandstones of that desert period. The ice has come and gone at least 4 times, and smaller advances and retreats have occurred in between. Between those big ice ages, the landscape was in what we call an interstadial, which was a much warmer period, indeed warmer than it is today at many occasions. The landscape that we see today, the Lake District landscape with its glacial valleys and ridges and corries, has been carved by those successive ice ages. And the dominant shapes and patterns that we see are the result of the very last ice age. At its height, the Lake District was covered by an ice cap, and the ice would have flowed from the Central Fells outwards in all directions towards a coastline that was far further away than it is today, with a sea level maybe 100 or 150 feet lower than it is today. Only the very tops of the highest mountains, Bowfell, Scafell Pike, remain clear of this ice cap. And they have quite a different character today. Boulder-strewn tops caused by the frost shattering that the rocks were exposed to during the ice ages, but those rocks never cleared away by the movement of the ice. Elsewhere, every ice age scoured the surface of the rocks clear of any loose material, and each time created smooth surfaces polished by the ice and the rocks that it carried, scratching it like sandpaper into smooth and rounded shapes. The very last ice age was mostly a valley glacier ice age. Rather than an ice cap, each of the valleys of the Lake District was occupied by a deep valley glacier, almost to its top. So the crags that line the very tops of each of the valleys were frost-shattered throughout this period. It became jagged as a result. It's easy to see today, looking up the side of any lakeland valley, where the glaciers of that last ice age reached to. Below the line, the rocks are all smoothed and rounded and striated by the scratches, the rock caught in the ice, carved into them. Above that line, the rocks are shattered, angular, and broken, and from those crags today form the scree slopes that run down into the U-shaped valleys that were carved by the glaciers. Those rocks would have been carried away by the ice whilst it was present in the valley, but today they fall down from the crags and pile up in these steep screes, the largest material at the base having rolled all the way to the bottom, and the smallest material stopping near at the top. After the Ice Age, the rivers also would have been supercharged with large quantities of material left as by the retreating ice, the moraines being reworked and washed down the valleys. Most of the erosion of the fluvial features of the Lake District would have occurred at this time. They're relic now, the rivers looking small compared with the valleys they now run in. Many of these rivers form little gorges, now called gills in Lakeland dialect, and these gills are cut into the mountainside by the streams that would have poured off from the melting snow, following the fault lines in the underlying rocks, the volcanics and the sediments. So instead of having a snake-like meandering appearance, they drop down the fellside in right-angled leaps, coming straight down a fault line, taking a right-angled turn, following another fault line across to the next line that takes them down the hill towards the valley bottom. The faults in the rock provide another typical part of the Lake District's geology, which has had a big impact upon its history as well, that the weaknesses in the rock caused by the faults provide planes, lines along which hot fluids and gases deep in the crust of the earth can escape. They use them as a way up towards the surface. These fluids are charged with steam and gas, so they move quite freely through very small spaces. As they move upwards into the crust, of course, eventually the temperature drops, and it drops to the point where they can move no further because the minerals in the fluid go solid and the steam carries on and it dissipates. The commonest mineral you find in these veins is quartz and a good deal of iron as well, because these are the commonest minerals in the Earth's crust. Quartz has the lowest melting point of all the common minerals, so it's the last one to go solid. About 1 million years ago, something changed in the global climate. It could have been to do with the orbit of the Earth around the Sun, the angle of tilt, the Earth's axis to the Sun, or indeed sunspot activity, or maybe a combination of these things that triggered an ice age right across the globe. At this time, wet westerly winds would have been blowing off the North Atlantic, causing heavy rainfalls just as they do today on the west coast of the British Isles. But the climate changed enough for that to fall more as snow, especially in winter, and less as rain. And the balance between the amount of snow that could melt and the amount of snow that was building up was turned around, so that gradually, year on year, snow accumulated deeper and deeper and deeper, permanent snow, eventually reaching a depth where the weight of the snow turns the old deep snow buried at the bottom of the snow patches into a blue ice called neve. Neve has a property that it can deform very slowly under its own weight. In other words, it can move as a solid, and this is what allows the ice to begin to move ever so slowly, though ever so slowly can be meters a year. And the ice moves in a series of scoops, so that instead of carving out a nice gradient, steep near the source and shallow and gentle near the sea, it goes down in a series of scoops, digging deep down and then easing off to form a lip, and then digging deep down again, forming another lip. The material in the valley gets scooped up by the ice and carried along with it, and it's that material in the ice that does most of the scouring, most of the erosive work, bumping into and scratching the surfaces over which the ice moves. And those trenches, where they haven't filled in with sediment since the Ice Age, been filled up with water to form the 14 or so lakes that radiate out from the Central Fells, including the largest lake in England, of course, Windermere. Scientists have often wondered whether ice ages come slowly and go slowly, or whether the switch from the warm, temperate climate to the cold ice age climate is sudden. Evidence suggests that it can be indeed very sudden. Some people think that the last ice age, the temperatures switched from a level where ice was accumulating and the glaciers were advancing to a situation of retreat and warming in a matter of maybe 80 years, even perhaps less than that. So the switch in the world's climate, it seems, can be caused by some trigger that changes the temperature regime of the planet very quickly. It would only take a change in the temperature on the tops of our mountains of 2 degrees centigrade on average for the ice to return to the Lake District as a permanent feature.